Yes, student, here the problem. There is a 100-meter high tower and a ball is thrown from ground just to reach the top of tower. The velocity u of the ball, vertical position that it can reach the top of tower. At same time, when ball was thrown from the ground, another ball is dropped. Another ball dropped from the top of tower. Drop means that start falling down. So at what height the two balls will cross each other? The height of tower is 100 meters. This ball from the ground is thrown in such a manner that it can just reach the top of tower, and at the same time another ball is dropped from top of tower. At what height they will meet? One thing I want to tell you here, we have learned equation p equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. These are equations for uniformly extended motion. Under gravity, when a body falls from certain height or we throw a ball up, that motion of that body is under accessory to gravity, which is g, small g. So in place of a we can use g there. In case of s we can use height there. And a is positive negative, means g is taking positive negative. If velocity there, if we throw ball upward, then velocity decreases, the acceleration is minus. So here minus is drop from top, that it increases to plus g. But there are some problems where we use the vector forms. I will do the problem also. This one or this one can be used in vector form, whether under gravity or somewhere else. But here now what is happening? Ball you have thrown from ground just reach 100-meter high tower. It means its velocity is that when it reaches, its v becomes 0. So in the equation v square equal to u square minus 2gh, v 0 and u square minus 2g into 100. What is u? U is the velocity of ball thrown from the ground. So here u square equal to 200g or u equal to under root 200g. We will solve it later on. So velocity of ball thrown from ground which just reached the top of tower is this. Now question is asked when they will meet. Since both start simultaneously, so if we are let two balls meet at height h from the ground, then time taking by ball to reach height h is equal to time taking by other ball to fall height 100 minus s. Suppose they meet at this height. If this ball lies height x, this ball falls height 100 minus s. They start simultaneously, so time to go height h by this ball and time to fall height this ball 100 minus s is the same. Let it be t. Let this time be t. from equation h equal to ut minus half dt square. So h equal to u 200 g under root into t minus half dt square. This is for ball from the ground. Now for ball falling from top, ये इक्वेशन की होगी 100 minus h equal to 0 plus half dt square. These are two equations. If we add these two equations, what do we get? Adding these equations. 100 equal to under root 200g into t. So from here t equal to 100 upon under root 200g. This is the time taken by the ball to rise height h and to fall this. Put this value of t in equation 2. Using this value, we are using t equal to 100 upon under root 200g in equation 2. We get 100 minus h equal to half g into t square, 1000 upon 200g. G cancel. Have 2 4, 25. So h equal to 100 minus 25, 75. So the two ball will meet at height 75 meters from the ground. This is a simply good question to apply our brain and to understand how to solve problem. Now there is other question. Again, this question I am telling you has been asked in many exams. When I started my teaching, the class 11 paper was set by CBSE. Checking was done in the school, but paper was set by CBSE board. At that time, this question came 2 times from the board. क्या था क्वेश्चन? A car starts from rest and accelerates at constant rate alpha for some time, and then starts retarding at constant rate beta, and finally comes to rest. If total time of journey of car B is small t, then prove that maximum velocity attained by car. V maximum equal to alpha beta t upon alpha plus beta, and total distance of journey alpha beta t square upon L into 2. Car start from rest, accelerate at constant rate alpha, and for some time and then start retarding and at constant rate beta, and finally come to rest. Suppose here I represent u0 alpha for some time and beta retardation and finally v0. So what is maximum velocity? So the maximum velocity will be at the end point where you stop accelerating and it start decelerating. That point P here, it is starting point O and this is Q. That time taken to travel T dash, total time journey T. So how to prove? Again from equation V equal to U plus AT. V maximum 0 plus alpha T dash. Yani V maximum is equal to alpha T dash. Here our problem is that T dash we have imagined. It is not given that how much is T dash. So we have assumed that time taken for acceleration at rate alpha is T dash. Now we have to determine T dash in terms of P. From here car start turning and finally comes to 0. Again from same equation 0 is equal to V maximum minus beta T minus T dash. T minus T dash the time of this journey from here. V maximum alpha T dash 0 alpha T dash minus beta T plus beta T dash. And from here we get T dash into alpha plus beta equal to beta T. Rearranging this equation. T dash common alpha plus beta minus beta T 0. All this thing. So from here we get T dash equal to beta T upon alpha plus beta. So V maximum is equal to alpha beta T dash put here T upon. Simply exercise your brain, nothing else. Actually we have to concentrate on the problem, what are the given facts, what is the problem and what do we know about the problem. So we have got V maximum, total distance travelled. Let from O to P be S1 and from this be S2. And S1 plus S2 equal to S. So for S1 body start with U equal to 0 and achieve maximum velocity. For S1 body or car starts from rest. With acceleration alpha and achieve velocity V maximum. From equation third, V square equal to U square plus 2AS. V equal to V maximum square. 0 plus 2 alpha S1. V maximum you have to determine here. So it is alpha square beta square T square upon alpha plus beta whole square 2 alpha S1. From here S1. So S1 is equal to how much? this alpha cancel power alpha beta square t square upon 2 alpha plus beta whole square. तो S1 ये एक्चुअली और S2 U equal to V maximum and V0 again using same equation 4S2 U equal to V maximum ये लिखिए अल्फा बीटा टी अपॉन अल्फा प्लस बीटा and V equal to 0 and A equal to minus beta. Using third equation again, V square equal to U square plus 2AS, V equal to 0, V maximum square minus 2 beta S2 or 2 beta S2 equal to V maximum square alpha square T square beta square T square upon alpha plus beta whole square. I have put the value of V maximum. From here beta equal to alpha square beta T square upon 2 alpha plus beta whole square. I think you are enjoying the problem. But you enjoy or not, but I am enjoying. Total distance S equal to S1 plus S2. What is S1? Alpha beta square T square upon 2 alpha plus beta whole square plus S2 alpha square beta T square upon 2 alpha plus beta whole square. What is common? Alpha beta T square common upon twice alpha plus beta whole square. Here will be beta plus alpha. So this is 1, this is square. So S equal to alpha beta T square upon twice alpha plus beta. This is the total path length. There is no end of problems. Dear student, get some textbook and start solving problems in class 11. Actually you are starting from ground level. There is no difficulty, but difficulty in our thought that we never fight the problems. You have to fight the problems. You have to think, you have to sit. Don't think that I could do only one question in 1 hour. It will take time initially. In my teaching experience, I noticed up to half yearly exam, students of class 11 remain confused. I am not able to solve problem. I don't understand. We have to sit. We have to take time. And imagination has to be increased. Now I will tell in next video the question used on vector form.